The grey winter light over Kummersdorf proving ground had the colour of cold iron. It was the morning of November the 21st, 1943, and the engineers from Wa Prüf 1, the German Army's weapons testing branch, stood in a semicircle around a captured American weapon resting on a wooden trestle. Its olive-drab paint was scratched, its simple steel tube dented in several places, its trigger assembly held together with little more than pressed sheet metal and screws that looked almost civilian. Oberingenieur Kurt Fromm, who had spent 12 years designing the precise clockwork of German anti-tank launchers, lifted the object with visible distaste. He weighed it in both hands, just under 6 kilograms, and frowned. "Primitive," he murmured. "Amerikanisch." Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. Yet that primitive object, stamped M1A1U-S Army, had stopped a Panzer IV outside Salerno only weeks before. The story of how it arrived here began on the beaches of southern Italy, where the Wehrmacht first met a weapon it could neither classify nor ignore. On September the 13th, 1943, as German forces attempted to push the Allied beachhead at Salerno back into the sea, Oberfeldwebel Hans Müller of the 16th Panzer Division watched one of his company's tanks lurch to a halt. There was no explosion from artillery, no telltale whine of an armor-piercing shell. Instead, a short streak of smoke, barely 30 meters long, had shot from a hedgerow, and the tank's side armor had been punched clean through. The crew barely escaped before fire reached the ammunition racks. The after-action report described a small rocket-like projectile, fired from the shoulder, capable of piercing 50 millimeters of armor. German intelligence officers dismissed it at the Maine first. Infantry weapons, they argued, could not defeat modern tanks. Such results must have been luck or sabotage. But within days, similar accounts reached command posts at Eboli, Battipaglia, and Vietri. The same weapon, fired by British and American infantrymen, was appearing everywhere. When one was finally captured intact, Major Wilhelm Voss of the Army Weapons Office sent it north for immediate analysis. By October's end, it had reached the Kummersdorf range outside Berlin, the same facility where, 2 years earlier, German engineers had examined the Soviet T-34 and been forced to rewrite their doctrines of armoured warfare. Now they stood once more before a foreign artifact that seemed to mock the complexity of their own designs. For the German officer corps, anti-tank warfare had always been an affair of precision and metallurgy. Their infantrymen carried the cumbersome Panzerschreck of the first generation, what they called the Ofenrohr, or stovepipe, a heavy tube that required special ignition equipment, a protective blast shield, and a 2-man crew. Its ammunition was costly, its manufacture exacting, its operation dangerous. Before 1943, no one in the Army Weapons Office imagined that a soldier could destroy a tank with something he could carry like a rifle and build almost as easily. The idea violated both engineering logic and institutional pride. In the German worldview of that time, sophistication equaled superiority. Each piece of equipment embodied what they called Deutsche Gründlichkeit, German thoroughness, precision machining, fine tolerances, multiple safety interlocks, and polished fittings that spoke to craftsmanship as much as to killing power. To them, war was an engineer's contest as much as a soldier's. The early test notes of the Kummersdorf staff read like disbelief turned into reluctant admiration. Test 1. Armor penetration at 30 meters, complete perforation of 55 millimeters of roll, homogeneous plate. Test 2. Ignition reliability satisfactory, though ignition battery questionable. Test 3. Cost analysis, estimated production time per unit less than 1/10 that of the Panzerschreck. Fromm turned to his assistant, Lieutenant Georg Krüger. "They've built a child's toy," he said, "and it kills tanks." Krüger, 26 years old, and trained at the Technische Hochschule in Munich, noted quietly in his diary that evening, "For the first time, I think perhaps our genius has betrayed us. The Americans make weapons for the common man, we make them for specialists. And war has no patience for specialists anymore. To understand why this simple tube of steel shook the faith of German engineers, one must look back to the philosophy that had guided their designs since the interwar years. After the defeat of 1918, the Reichswehr had been bound by the Treaty of Versailles to a token army. Its officers, forbidden heavy weapons, studied theory instead. Out of this came the cult of the Kampfwagenabwehr, the science of destroying tanks through coordinated, technically superior means. The interwar workshops at Rheinmetall, Krupp and Mauser produced precision anti-tank rifles, 3.7 centimeter guns, and elaborate shaped charge warheads, each marvels of engineering, but all expensive and slow to build. By 1941, as German forces advanced across the Soviet Union, they found themselves facing the T-34 and KV-1 machines against which their light anti-tank guns were useless. The response was to scale everything up: larger calibers, heavier guns, longer barrels. Complexity multiplied. Infantrymen at the front were left with little they could carry themselves. The light Panzerbüchse rifles became obsolete. Field guns had to be towed, emplaced, aimed with care. When the Panzerschreck appeared in 1943, a clumsy 70mm rocket launcher requiring a protective shield against backblast, and was considered a breakthrough, yet even it demanded industrial precision, fine machining, special electrical firing circuits, heat-resistant materials. Then came the American Bazooka. In appearance it was crude, even laughable. Its body was just a thin steel tube open at both ends. The trigger mechanism was a childlike arrangement of dry cell batteries, wires, and a contact switch. The rocket, about 1.5 inches in diameter, carried a simple shaped charge warhead with a copper liner and an explosive compound known as composition B-RDX and TNT mixed in proportions that any German ordnance chemist could recognize. What astonished the engineers was not the science, it was the simplicity. Every part could be fabricated in minutes, not hours. The tube required no precision machining. The rocket could be pressed in assembly line conditions by semi-skilled labor. The electrical firing system, though inelegant, worked well enough in any weather. Fromm's report to the weapons office captured the grudging respect that would echo through the German armaments community for months afterward. This American weapon demonstrates that functional sufficiency outweighs craftsmanship. Its design allows manufacture by untrained labor. The projectile achieves penetration through correct geometry, not velocity. The entire system embodies expediency, without regard to aesthetic or theoretical perfection. The result, regrettably, is effective. For an institution built on the faith that excellence lay in precision, this was a theological crisis. When Albert Speer, the Reich's armaments minister, reviewed the Kummersdorf findings later that winter, he saw in them an uncomfortable reflection of his own struggle to modernize German industry. Germany's machine tool production was the envy of the world, but it was ill-suited to mass output. Every part demanded skilled labor and time. The Allies, by contrast, had embraced quantity over artistry. Speer noted in a memorandum to Hitler in January 1944 that the Americans have mastered the art of simplification to an extent that we cannot easily imitate. The bazooka was cited as an example of industrial rationality applied to war. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. By the early spring of that year, German workshops began producing their own simplified version, the Raketenpanzerbüchse 54, soon nicknamed the Panzerschreck. But the irony ran deep. The weapon owed its existence not to the genius of German design, but to the humility forced upon it by an American toy-like tube of steel. In the barracks of the 16th Panzer Division, soldiers who had once joked about Yankee fireworks now requested the captured launchers whenever possible. One letter recovered from the front, and later archived at Freiburg, describes a sergeant's experience outside Anzio. "We used the American tube against their tanks. It works better than ours, lighter to carry. You can fire it alone. Ours burns the face even through the mask. Theirs only smokes." Each such testimony chipped away at the old certainties, the belief that complexity was strength, that superiority meant refinement. By mid-1944, as Allied armies pressed toward the Rhine, the lessons of that captured bazooka would reach even the highest levels of German ordnance planning. Simplicity, once despised as crude, was now understood as the truest measure of wartime genius. Through the winter of 1943 into the spring of 1944, a quiet transformation spread through the German armaments bureaucracy. What had begun as an engineering curiosity at Kummersdorf evolved into an existential debate about the very nature of German design itself. At the center of that debate stood a small team under Oberingenieur Fromm, charged with developing a domestic equivalent of the American shoulder rocket. Their laboratory notebooks read less like invention than confession. The first prototypes appeared by February still heavy, still over-engineered. The engineers could not stop themselves. They replaced the bazooka's pressed steel trigger box with milled aluminum. They added removable sights, a blast shield of rolled armor plate, and a reinforced shoulder rest. When the first Raketenpanzerbuchs 43 was tested, it worked, but only barely. The weapon weighed nearly 12 kilograms, twice that of the American original, and the blast from its propellant scorched the operator's face. Soldiers nicknamed it the Ofenrohr stovepipe. Fromm's internal memo of March the 5th captured the mood. We have replicated the American concept, but not their spirit. Our craftsmen cannot imagine leaving metal unfinished or mechanisms exposed. Every man wants to improve, polish, refine, until the weapon again requires a factory to build. The order from the Army Weapons Office was blunt: reduce weight, increase range, simplify. What followed was a slow unlearning of everything the German technical culture held sacred. Designers discarded machining tolerances measured in tenths of a millimeter. They began stamping components instead of milling them. Welding replaced precision riveting. Electrical ignition, so distrusted by conservative ordnance officers, was kept because it allowed rapid firing. Within 3 months, the revised Raketenpanzerbuchse 54 entered production. It still looked German larger, more robust, but its soul belonged to the captured bazooka. Speer's factories in Magdeburg and Leipzig soon turned them out by the tens of thousands, each costing a fraction of a Panzerfaust or a field gun. By the summer of 1944, frontline units from Normandy to the Eastern Front were receiving shipments marked RPZ B-54. Elektrisch. The soldiers no longer laughed. In ruined villages and hedgerow country, these tubes of steel were sometimes the only weapons capable of halting Allied armor. The irony deepened as reports reached Berlin that American troops, in turn, were capturing the German Panzerschreck and using it against its makers. The cycle of imitation had become complete, a copy of a copy, each side learning from the other in the ruthless Darwinism of war. But the technical success masked a deeper wound. Within engineering circles, the bazooka affair had shattered a generation's faith in what German quality meant. The very characteristics that had once defined national pride, fine tolerances, complex mechanisms, an obsession with perfection, were now seen as liabilities. The war demanded not perfection but abundance. One evening in April 1944, Fromm and his assistant Kruger stayed late in their workshop. The radio in the corner murmured news of Allied bombings over Schweinfurt. Kruger, who had grown quieter as the months passed, finally asked, "Herr Oberingenieur, do you think we have been wrong from the beginning?" Fromm hesitated before answering. "No, Georg. Precision is not wrong. It is simply unsuited to chaos. We built for peace in a time of total war." He would not survive to see the end. When the Soviets overran Kummersdorf in April 1945, Fromm's notes were captured along with the wreckage of experimental weapons. His last entry, dated March the 28th, reads, "The genius of the Americans lies not in superior science but in humility before necessity." The technical implications of that humility were immense. The shaped charge principle, the idea that a conical cavity could focus explosive energy into a metal jet capable of burning through armor, had been known to both sides since the late 1930s. Yet, it was the bazooka that turned theory into practice by marrying that warhead to a lightweight, easily produced launcher. German engineers had treated the same concept as laboratory science. The Americans treated it as a tool for farmers in uniform. The difference defined modern warfare. After the war, Allied intelligence teams scoured German records and factories. Among the documents they recovered were side-by-side drawings, the American M1A1 and the German R.PZ B54. The similarities were unmistakable, yet the German version included dozens of extra machining operations, a heavier blast shield, and more parts than necessary. When these diagrams reached the United States Ordnance Department, one colonel scrawled across the margin, "They still can't resist improving things." In the immediate post-war years, those same German engineers, many of them now employed under Allied supervision, helped design the first generation of NATO infantry weapons. Their experiences during the war, and especially with the bazooka, had taught them lessons they would carry for life. Simplicity, reliability, and ease of manufacture became watchwords of the new era. The Panzerfaust and Panzerschreck lineage merged with Allied designs to produce the portable anti-tank rockets of the Cold War, the American M20 Super Bazooka, the French LRAC, and later the German Armbrust and Panzerfaust III. Each owed a conceptual debt to that crude American tube captured near Salerno. For historians of technology, the episode stands as one of the great ironies of the 20th century, that the most industrially sophisticated nation of its age was forced to learn simplicity from the country it derided as technologically naive. The bazooka was not the most powerful weapon of the war, nor the most accurate, but it revealed a truth that outlived all its creators, that in total war, the most elegant design is the one a common soldier can use without instruction, repair in the field, and manufacture by the million. When post-war interrogators asked surviving members of the Kummersdorf team what they had thought when they first handled the American weapon, Kruger, then a prisoner working under British supervision, replied simply, "We felt shame, because we realized that genius is not the opposite of simplicity. It is its servant." In that admission lay the quiet epitaph of an entire tradition of German engineering. From the ruins of the Reich, a new philosophy emerged, one that prized functionality above pride, and which would later power the economic miracle of post-war Germany. The lesson learned from a captured bazooka echoed far beyond the battlefield, that mastery sometimes begins not with invention, but with the humility to see perfection in the plainest things. The ruins of Berlin in the summer of 1945 smelled of dust and diesel. Among the mountains of brick and twisted iron, engineers who had once served the Reich now scavenged like the rest men who had once designed the finest machines in Europe, reduced to bartering for food with the same hands that had once drawn blueprints for tanks and aircraft. For those who had worked in the weapons institutes at Kummersdorf and Hillersleben, defeat meant more than surrender. It was an intellectual disarmament. Their laboratories had been stripped bare by Allied intelligence teams. Drawers of data, years of experiments, were boxed up and shipped across the Atlantic or the Urals. The last vestiges of Deutsche Gründlichkeit, German thoroughness, were now commodities of war. When the Americans arrived at Kummersdorf, they found not only the shattered remnants of V-2 rockets and jet engines, but also a small display cabinet containing the earliest test models of the Raketenpanzerbüchse. On one shelf lay the captured American M1A1 bazooka, the same specimen that had been the subject of so much disbelief in 1943. Its olive paint was chipped, its firing wires cut, but on its side someone had written in chalk, "Vorbild model." An American ordnance officer, Captain James Kirkpatrick, photographed it. His report back to Washington noted with quiet irony, "It is peculiar that our simplest infantry weapon should have inspired the most elaborate imitation. But the imitation had produced consequences far beyond the battlefield. During the war's last months, the Panzerschreck and its disposable cousin, the Panzerfaust, had become symbols of desperate defense. Young boys of the Hitler Youth, too small to carry rifles, were trained to use them against the advancing Soviet tanks. Many never survived their first shot. The blast backwash alone could sear lungs and skin, but the image of a child with a shoulder rocket became one of the final, tragic icons of the collapsing Reich. For the engineers who had built these weapons, this image was unbearable. The very instruments that had been born from technical admiration for the American bazooka had become tools of sacrifice for children. Fromm's assistant, Kruger, would later testify to Allied interrogators in 1946. "We began in professional curiosity, we ended in shame." Yet the story did not end with ruin. In the years that followed, the great powers rushed to translate wartime lessons into peacetime industries. The Americans took their bazooka back to the drawing board, improving its range, accuracy, and penetration. The new M20 Super Bazooka, with a 3.5-inch rocket, entered service in 1948. It retained the same essence, lightweight, simple, cheaply built. In Korea, it would destroy Soviet-made T-34 seconds with the same shaped charge principle that had astonished German engineers years before. Meanwhile, in the Soviet Union, captured German and American designs converged into the RPG-2 and later the RPG-7, descendants of the same idea, refined by necessity. The cycle of imitation continued, an American invention inspiring a German copy, which in turn informed a Soviet evolution. The world's future conflicts would be fought with the genetic descendants of that unassuming tube of steel first tested in the Italian countryside. In occupied Germany, the old engineers found themselves divided. Some, like Kruger, went into civilian industry. He became a production manager at a small tool-making firm in Hanover, applying what he called the lesson of the bazooka, that the simplest process is often the most efficient one. Others joined Allied research programs, quietly contributing to NATO's emerging weapons laboratories. A few refused rehabilitation. They could not reconcile their training, the old religion of precision, with the rough pragmatism of modern mass production. In their eyes, simplicity was not elegance, it was defeat. They retired into silence, watching a new world rebuild itself on principles they no longer recognized. In 1952, the newly founded Bundeswehr, West Germany's post-war army, began testing indigenous anti-tank weapons. Many of its technical officers were veterans of the Kummersdorf generation. When they examined the early prototypes, they rejected any design that required excessive machining or delicate alignment. One report, authored by Colonel Engineer Karl Mayer, stated, "Our equipment must be made for the soldier, not for the machinist. The experience of the last war has proven that the simplest weapon endures the longest." That sentence could have been lifted straight from the Bazooka Evaluation Report of 1943. The influence spread beyond armaments. In post-war factories, engineers who had survived the Allied bombings now faced a new challenge, rebuilding with limited materials and a devastated labor force. The doctrines that emerged, efficiency, modularity, interchangeability, were direct echoes of wartime lessons. A historian of German industry, Dr. Ulrich Lehmann, would later write that the reconstruction of West German manufacturing was built upon the psychological rubble of over-engineering. The miracle of post-war Germany, the rapid resurgence of its automobile and machinery sectors, owed much to that transformation of thought. Volkswagen's simple Beetle, Bosch's standardized electrical components, Siemens's modular appliances, all reflected a new respect for functional simplicity. Behind each stood men who, in another life, had over-designed weapons. For the Americans, the bazooka became an emblem of ingenuity, born from necessity. But for the Germans, it remained a mirror. Every captured example reminded them that technological arrogance could be a nation's undoing. The full irony emerged during the Allied interrogations that followed the war. In transcripts preserved at the U.S. National Archives, one exchange stands out. An American officer asked Kruger what he considered the most significant weapon of the war. The interviewer expected an answer like the V-2 rocket or the Panther tank. Instead, Kruger said simply, "The bazooka." But to the one that can be made by thousands of hands. The officer reportedly paused before replying, "That's something we're going to remember." And they did. By the time of the Vietnam conflict 2 decades later, the fundamental idea of a simple, shoulder-fired, shaped charge launcher had spread across every army in the world. Each nation called it something different: bazooka, Panzerschreck, RPG, but the essence remained. The weapon that began as a crude American experiment had become universal. In museums today, the M1A1 looks almost toy-like, a hollow tube, no sights worth mentioning, wires running along its side like something assembled in a basement workshop. Visitors walk past it quickly, their attention caught by the sleeker, deadlier weapons nearby. Yet, to the historian, that modest artifact represents a turning point not only in technology but in psychology. It marked the moment when German engineers, masters of precision, were forced to admit that simplicity could embody genius. It forced an entire culture of craftsmanship to confront the uncomfortable truth that beauty and effectiveness are not always the same. In the archives at Koblenz, one can still find a thin folder marked Kummersdorf, November 1943, Bericht über Amerikanisch Panzerabwehrwaffe. Inside are faded photographs of the captured bazooka, cross-section drawings, and the typed remarks of Oberingenieur Fromm. The final paragraph reads, "If this device represents the future, it will not be one of craftsmanship but of method. We must learn to think as they do not in perfection, but in sufficiency." That single word, sufficiency, would become the quiet foundation of post-war industrial design worldwide. In retrospect, the bazooka was never merely a weapon. It was a philosophy expressed in metal, that design must serve purpose, not pride, that the shortest route between problem and solution is often the truest form of intelligence. For the Germans of 1943, this realization came as humiliation. For the world that followed, it was liberation. As the 20th century progressed, the same principle spread beyond armaments into the very fabric of modern life. The consumer products, automobiles, and household tools that defined the era of mass democracy bore the stamp of this wartime awakening. Engineers who once designed killing machines now designed washing machines and radios with the same ethos of simplicity, modularity, and affordability. In that sense, the captured bazooka did more than puncture armor, it pierced ideology. Standing today in the quiet of a museum gallery, one can imagine that cold morning at Kummersdorf in 1943, the frost on the ground, the grey light on steel, the silence as German engineers stared at an artifact that upended their world. They had expected to find crude improvisation. Instead, they found an idea so elegant it needed no refinement. In the end, it was not the Tiger tank or the V-2 rocket that defined the future, but the weapon that required neither gears nor gyroscopes, a tube, a wire, a spark, and the acceptance that sometimes progress begins when complexity ends. The engineers who once despised that simplicity became, in time, its apostles. And the lesson they learned in defeat became one of the quiet victories of modern civilization, that the measure of genius is not how much one adds, but how much one can remove without losing strength. That was the legacy of the captured bazooka, an artifact that taught its captors humility, its imitators efficiency, and its inheritors the enduring truth that in the machinery of survival, simplicity is the highest form of sophistication. By the time the last shells fell silent in 1945, the war that had begun with science had ended with exhaustion. Factories that once built weapons of terrifying complexity stood empty, their machines rusting among the rubble. Yet, in that silence, a quieter kind of engineering began, one not measured in calibers or armor thickness, but in understanding. Among the thousands of captured documents stored in Allied archives, a small folder labelled Bazooka German Evaluation became an unlikely point of study for both victors and vanquished. It was passed among ordnance departments, universities, and later design schools as a case study in applied pragmatism. Historians would call it a parable of humility in steel. The report contained little drama, only notes, measurements, and sketches, but between its lines lay a revelation that would shape the century to come, that the brilliance of a tool lies not in the skill required to make it, but in the freedom it gives to those who use it. For the Americans, The bazooka was a triumph of necessity. It was born from shortages, from the improvisation of scientists in a rush to arm soldiers who had no tanks of their own. For the Germans, it became a mirror reflecting their own excess precision elevated to dogma. When their engineers looked down the crude barrel of that American weapon, they saw something that contradicted everything they had been taught. Simplicity had beaten sophistication. Function had humbled form. In the decades that followed, that truth echoed far beyond the battlefield. Designers of cars, cameras, and computers would speak of the elegance of economy, a philosophy that traced its lineage back to a cold morning at Kummersdorf, when a group of engineers, for the first time, admitted that less could indeed be more. The bazooka had no beauty, but it had purpose. It could be built in a day, repaired in a field, and understood by a farmhand. That, in the end, was its genius. From that insight grew a new kind of engineering, one that valued accessibility over artistry, reliability over refinement. When post-war Germany rebuilt, this mindset quietly guided its rebirth. Volkswagen, Siemens, Leica all began to design for universality, not elitism. Their machines spoke the same language the bazooka had once whispered. Make it work first, make it beautiful later. The same engineers who had once admired the flawless fit of machined parts now taught apprentices the virtue of the good enough. They had learned, painfully, that perfection pursued without restraint could destroy as easily as it could create. There is a surviving photograph of Oberingenieur Fromm's old team taken in 1956 at a reunion in Hanover. They stand in front of a factory gate, older, thinner, their expressions distant. On the back of the photograph, someone has written a single phrase in pencil. Wir haben gelernt. We have learned. No one knows who wrote it. But those 3 words summarize the moral far better than any textbook. Because what they learned was not merely how to make a simpler weapon, it was how to think differently. How to see efficiency not as compromise, but as clarity. How to recognize that intelligence is measured not in the complexity of what one builds, but in the honesty of why it must be built at all. That lesson outlived the men who first discovered it. It traveled through post-war design offices, through NATO research labs, through the quiet corridors of engineering schools. Every time a young designer stripped a mechanism down to its essentials, every time a product succeeded because it was simple enough to be universal, the echo of that captured bazooka sounded again. In the 21st century, when engineers design tools for space, medicine, or technology, they still invoke the same rule that Fromm wrote in his final notebook. The simplest solution that works is the most perfect form of intelligence. It is an idea that bridges eras, from the smoke of war to the circuitry of peace. And perhaps that is the true legacy of that unlikely weapon. It killed tanks, yes, but it also destroyed an illusion. The illusion that complexity is the highest expression of genius. In doing so, it gave birth to a new humility that reshaped not just armies, but civilizations. Today, when we look at the rusted remains of a bazooka in a museum case, its paint flaked, its wires brittle, it seems an artifact from another world. Yet its message remains current. Every student who studies its form sees not a relic of destruction, but a testament to human adaptability, the ability to learn, even in defeat. History often remembers inventions by their impact on the battlefield, but some weapons, like this one, change the world not by what they destroy, but by what they teach. The German engineers who examined that captured bazooka could never have known that their moment of humility would outlive their empire, their language of war, and even their generation. Yet through that moment, they contributed to something lasting, a universal principle whispered across time. That simplicity, when guided by necessity and understood through humility, is the purest form of brilliance. And so, in the final reckoning, the story of the bazooka is not one of imitation or conquest, but of revelation. It is the story of minds transformed, of a civilization rediscovering wisdom in the very thing it once dismissed as crude. It is proof that even in war's darkest hours, learning does not end, it merely changes its teacher. In the end, The captured bazooka taught more than it destroyed. And that, perhaps, is the most remarkable victory of all. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.